All right, here we go. One last try. Oh, my fusion design was so simple, I didn't expect to run into so many problems. All of this started a few weeks ago when Before we dive into it, this video is sponsored by Things.com, a new 3D model community. Stick around to learn more about them and how you can win a 3D printer. A few weeks ago, I was excited to finally get a vacuum former. I ended up getting the Form Box by a company called Meiku. This all started when I unboxed the product and I was practicing with these example objects that come with it. My favorite was this phone holder, so I decided to try to cast it with resin, but I realized my phone doesn't actually fit in here when I have the case on. So of course, I jumped right into Fusion 360 to design my very own phone holder. I started the model by sketching the side profile. There were two reasons for this. First, the most important aspect of this design is this slot where the phone sits. From the start, I needed to ensure the width of my phone, with its case on, would fit within this tray. Second, adding draft angles is critical in making sure 3D printed objects can be released from any mold, especially when it comes to vacuum forming. If the walls of your object are 90 degrees, then it creates too much friction on the sides while also trapping too much air. To avoid this, we need to follow the general rule of adding a 3 to 5 degree draft angle to all the side walls. You'll notice that I played it safe by using a 5-degree angle for both side walls. With that said, these inner walls are just as important. I added a 5-degree angle to these as well. You'll notice I don't have dimensions here because I use the parallel constraint. Now this is a best practice in any parametric CAD program and where I see a lot of users go wrong. When possible, you want to keep the dimensions to a minimum by referencing existing geometry through the use of constraints. We can simply select the parallel constraint, followed by selecting the two lines. That ensures that everything is driven from this 1 degree. This top portion is the last thing to consider. The overall width of this holder is crucial in making sure the phone holder doesn't tip over. However, I didn't like the idea of this top portion going to waste. As I pondered ideas of what to do with it, I realized that I always have a pencil sitting on my desk. I decided to sketch out an arc to create a shallow tray for a pencil to rest. I also wanted to be able to drive the position of the arc from a single dimension. I constrained everything to this construction line, allowing me to change the position by simply altering the dimension. I ended up going with 6mm as this can't be too deep or the plastic won't be able to form around it. This also avoids any undercuts from the arc curving back to the center. The next step was a simple extrusion. However, you'll notice I used the symmetric direction type. This allows the extrusion to go in both directions at the same time. I did this as I wanted the sketch profile to be in the center instead of the edge. That allows me to keep an eye on the shape as I proceed by adding the remaining draft angles and fillets to the edges. A quick tip, if you ever need to look at a specific face of the model, you can click to select a face, followed by the Look At button at the bottom. Notice how that reorients the model to look at the selected face. From this view, you can clearly see those 5-degree draft angles. However, if I rotate to the adjacent face, you'll see that those walls are still at 90 degrees, which is going to be a big problem for the mold. To fix this, we can use the Solid Modeling Draft command from the Modify dropdown. With the draft command, we simply need to select the desired faces along with a single pull direction. The pull direction can be any face in the same direction the object would exit the mold. Notice this white arrow. We can select it if we want to flip it to the other direction. Of course, the most important thing is the draft angle itself. In this case, I added a 5-degree angle to match the adjacent faces. However, you can define any angle by rotating the degree slider or by typing out a degree in the dialog. At this point, all the faces have the required draft angle, ensuring the object can be released from the mold. We have two final things to consider when designing for vacuum forming. First, we'll need to add holes anywhere we have an inner cavity. This ensures the plastic can be sucked into the cavity. Without the air holes, there would be nowhere for the air to escape except out the sides, which will result in a poorly formed model. I simply created two different sketches containing 4 circles. I then extrude cut them away from the solid body, resulting in these 8 air holes. The key consideration with these holes is that they need to be small enough that they don't affect the mold. This is one of the first problems I ran into with my initial prints in vacuum forms. Through some trial and error, I found that 2 mm was the optimal size that allowed the air to pass through without leaving noticeable divots in the final mold. Last but not least, we need to add fillets to soften all the edges. With the fillet command, I first added a 7 mm fillet to all 4 corners. This will not only soften the design of the holder, but it will also help the object exit the mold. The second critical fillet is this inner slot. We need to add enough of a radius so the plastic can actually bend with the shape. The deeper a plastic sheet is stretched, the thinner and weaker it will become. I ended up adding a small 2 mm fillet to both these inner edges. I then used a separate fillet command to add a 1 mm fillet to all the remaining edges, ensuring they're soft enough for the plastic to form around. This will also ensure the final resin object doesn't have any sharp edges. Now, I did this as a separate fillet so I can right-click and suppress the feature when needed. This allows me to look at or work on the model with only the required fillets. Before I show you some of the problems that I ran into, let's talk about the sponsor, Things.com. Things is a new 3D model community, and you're probably wondering, how does it differ from Thingiverse? For starters, Things uses AI to scan and index every single model. That means you can use the site to search for models based on similar geometry. As the community and model base grows, Things will basically be the equivalent of Google searches but for 3D models. Now, unlike other sites that only rely on titles or descriptions, Things actually takes the 3D data and translates it into code, which can then be referenced across all the millions of 3D models. Things.com was also just released a few weeks ago. That means you can play a key role in how the site gets developed by providing your ideas and feedback. That's also why I'm excited to partner up with them to bring back the 3D modeling challenge and to give away a 3D printer. The winner will get a brand new Ender 3 Pro 3D printer. Now, this first challenge is all about having a tidy desk, so be sure to upload as many submissions as you would like by October 9th. Back in Fusion 360, there are 2 more things that we can do to double check the model before we try to make a mold. The first tip, anytime you're modeling something for the exterior geometry, it's a good idea to toggle your display settings. Head down to the display settings, visual style, and then select the shaded option. As you can see, this gives a more realistic look when compared to the one with edge lines. It's a great way to visually check the model for any irregular geometry. Lastly, we can use the draft analysis from the Inspect dropdown. This feature analyzes whether or not our design can actually exit a mold. We simply select the body, followed by selecting a face in the direction the model will be released. As you can see, everything on top should be green, and any red areas indicate an undercut or area of the design that may not release from the mold. After a quick check around the model, everything looks good. At this point, I decided it was time to export the model to Cura, where I sliced it and sent it off to the Ultimaker. 5 hours later, the model was done and ready for the vacuum former. A vacuum former works by placing a sheet of plastic, usually PETG, which is then heated up until it's flexible. You then slide the plastic down over the object, and a vacuum kicks on to help suck the plastic around the object while removing the air. At first, I hollowed out the Fusion 360 model to cut down on the print time. However, the temperature of the vacuum former ended up warping the part while the sheet was being formed. Using ABS instead of PLA filament may have helped, but I instead decided to make the model completely solid as we looked at earlier. Of course, the inside of the print only has 30% infill, but it's rigid enough to keep it from warping. The second issue I ran into came when I poured the two-part resin into the mold. Thinking that my draft angles are sufficient, I didn't consider a release agent. Thus, my first pour remains forever stuck inside the mold, and you can see that I even gave up trying to cut the mold. After some research, I discovered that a small amount of Vaseline or some cooking oil is the perfect solution. This two-part epoxy is one of the few that has little to no odor. I picked it up on Amazon for about $25 US. Overall, resin is still not the cheapest thing, so I used Fusion 360 to estimate the amount of resin needed. Now you first have to right-click on the component or the bodies to make sure the physical material is set to the appropriate option. The default is steel, so drag and drop water onto the component. You can then right-click and select the Properties option where you'll find the volume. I converted the volume into ounces, where I then measured out the approximate amount of resin. A quick mix with a popsicle stick, and I poured everything into the mold. You'll also see that I trimmed away the excess of the mold so it could rest on an old plastic container. This not only helps keep it level, but also allows some airflow underneath as resin gets quite hot as it's curing. After 15 minutes of waiting, the resin turned solid white and was cured enough that I could flip the mold over to release the new phone stand. Hopefully you learned some tips and tricks in this video. Be sure to check out the links below in the description for the 3D modeling challenge and for project materials. Also, go ahead and comment below and let me know if you like these project-based tutorials and if you have any tips for working with resin. Last but not least, I want to give a quick shout out and thank you to all the new patrons and supporters who bought me coffee over the last 2 weeks. Thanks for contributing to my mission of making CAD education accessible to all. Be sure to subscribe if you haven't already, then click on that playlist in the lower right-hand corner to watch some more 3D printing projects.